All right, welcome to another great video lesson by Mr. Zent. Today we're going to go through solving systems of equations using matrices. Our goal here will be to determine the dimensions of matrices and to solve system of equations in 2 and 3 variables using technology. This is really helpful if you ever end up in a physics class working with electrical circuits, resistance, and all that kind of stuff, and a number of other scenarios where you're going to have multiple variables, especially as they become more than just 2 equations, 2 variables. All right, the dimensions of a matrix are the rows by the columns, okay? So just so you remember, columns are up and down, they're vertical. This would be a column, and these are rows, okay? So just so we're aware of that. And our dimensions on something like this here, if I look at it, I'm going to clean these off first, since we now know what rows and columns are. Our dimensions would be the number of rows. Well, we have 1 row and 2 rows. So we have a total of 2 rows by the number of columns I have. 1 column, 2 columns, 3 columns. So our dimensions of this matrix would be a 2 by 3 matrix. Okay? Great. Looking at the dimensions here, again, we start off with rows. We have 1 row, 2 row, and 3 rows. So our dimensions is going to be a 3 by, and the number of columns are 1 and 2. So a 3 by 2. And then finally for this one, we have 1, 2, 3 rows, and only 1 column. So it's a 3 by 1. Okay? So apparently matrices can come in different shapes and sizes. We've gone through how to determine dimensions. The big idea that it's rows by columns. If you remember that, you're halfway to getting this lesson correct. All right, so our steps for entering your matrix. The first thing we're going to do is open up our calculator. I bring that up here. And I'm always going to start by hitting second and then the matrix button. The matrix button is our x to the power of -1. If you'll see here, I'll even highlight where it says matrix. Or maybe I won't. Oh, there it goes. Okay. Matrix is a green key, or a blue key. Sorry, it's a blue key. So I hit the second button to get there. I'm now going to try to delete that. So now I go second, x to the power of 1, and I enter in my matrix area. All right. I go to matrix and right arrow over to edit, enter. So again, I'm going to go over to edit, and I'm going to hit enter. Okay. I'm then going to enter the size of the matrix. In this case, I have a 2 by 3 matrix, so I enter the size there. And then I go ahead and I type my system in without variables. Again, it's very important that you're typing this in without variables, okay? Also, keep your signs. Do not drop negative signs just because you don't like negatives, all right? After you've entered in your matrix, you're going to hit second mode to quit, okay? Then you have to go right back into the matrix. It seems silly, but you have to do it. You're going to right arrow over to math and then scroll down to ref and hit enter. So again, I would go back into my matrix, second, x to the power of 1. I go over to math. Notice the red lights are showing up on the buttons I'm touching. I go over to math, and I'm going to go down to ref. All right, so as I said, I'm going to go down to ref. I'm just going to hit that down arrow key for a while. I think it's letter B. Ref, I'm going to hit enter. And when I ref, I'm going to put the matrix. I'm going to then go back in the matrix one more time here. So second, x to the power of 1. And the matrix I'm working with is my first matrix. This is the one I'm working with. You'll notice it has the letter A to it. So I'm going to select that. I'll clear all that stuff out of there. And now it says ref matrix A. I'm going to hit enter, and I should get some kind of matrix, okay? Our matrix value will look something like this. I'll have 1, 0, and then a number. That's my x value, because after all, this would be the equivalent of saying 1x is equal to whatever this number is. Down here, I'll say 0, 1, and a pound. That would be the equivalent of saying 1y is equal to whatever that number is. Okay? That's how this works. So 1, 0 will tell you your x value, 0, 1 will tell you your y value. So we're going to solve this system using matrices. So the matrix I'm going to enter in is going to be based on these coefficients. The coefficient on x is 1. So my coefficients would be 1, 2, -1, and then for my second equation, 4, 3, and the constant 9. This is what the matrix is going to look like that I'm going to enter. So now I'm going to go ahead and do that. So I'm going to go second, x to the power of 1. I'm going to go down to edit because I want to change my matrix. I'm going to matrix A. It is a 2 by 3. 1 row, 2 row. 1 column, 2 columns, 3 columns. So it's a 2 by 3. All right. So I can just go through there, hit enter, enter, and I'm going to start entering in my values. 1. And then I'm going to hit enter. Then I'm going to enter in 2, hit enter, -1, hit enter, 4, hit enter, 3, hit enter, and then -9, enter. All right. At this point, I'm good. I'm going to go to second quit. Then I got to go back into the matrix for a second time. I'm going to select math. Now I found that the up arrow key sometimes will get you to RF quicker than the down arrow key. It doesn't matter. Go up, go down. You'll get to RF. That's the key. Hit enter when you get there. You'll see RF. Now I'm going to go back into the matrix for a third time by going second x to the power of -1. Might feel like Neo at this point, going in and out of the matrix, but that's okay. I'm going to select enter at A. So I'm working with matrix A. That's the one I've been dealing with. I'm now going to hit enter, and I'm going to get my answer. And my answer here is that x is equal to -3, y is equal to 1. So I would have my solution would be at the intersection of -3, 1. Now, before I just accept this computer answer as if it's divinely inspired, I'm going to go ahead and plug my values of -3 for x and 1 for y into this problem and see if that works. Okay? So let's go ahead and check that out here. I'm going to move this over to here. I already know what my answers are. So on my first equation, I would enter in -3 for x plus 2 times 1. And when I do that, I get -1. So that checks out. Looking at the second equation now to check that, 4 multiplied by the input of -3 for x plus 3 times my value of y, which is 1. That better be equal to -9, and indeed it is. So my answer is indeed for this problem -3, 1. This is much quicker than trying to solve this by elimination. By solving it by elimination, I'd have to multiply the top equation probably by -4, add them together, solve for x, solve for y, eliminate x, solve for y, then plug it back in, solve for x. We'd still be working on it. Let's move on to the next example. In this one, we have x is equal to -2y plus 6, and x plus 2y is equal to -4. Notice, this is not in standard form. It has to be in standard form. So there are two options. I could go ahead and just solve this by substitution, which is a logical option, or I could actually solve this by matrices. Now I'm going to tell you this problem is actually easier to solve using substitution than matrices. But we're going to go ahead and solve it anyways by using the matrices, which means I need to take x equals to -2y plus 6 and write it in standard form. Standard form again is ax plus by is equal to c. That's my standard form. I'll just write it out, standard form. So to get it in standard form, my x and y need to be on the same side. So I'm going to move this over here. The way I move it over here is adding 2y to both sides. I cannot combine x and 2y because they are problems. They have different variables. So I'm going to end up with x plus 2y is equal to 6. Which means now on my other equation, so this is equation 1, equation 2 is x plus 2y is equal to negative 4. Hopefully as you look at this, you realize, wow, that's not going to work, right? You should be able to notice that at this point. They're the same, everything's the same on the left, but they're different on the right. These shouldn't come out to a solution. So we're going to see what that looks like. It's always good to be observant. By the way, what I'm going to enter into my calculator for my matrices would be 1, 2, and 6, and then 1, 2, and negative 4. Again, this is all trending towards no solution. But we'll find out just to make sure. So now I go to second x to the power of negative 1 to get into my matrix. So second and then the matrix key basically. I go over to edit. I hit enter and A. I hit enter because this is still a 2 by 3. 2 variables, 2 equations is going to be a 2 by 3. I enter in 1, hit enter, 2, hit enter, 6, hit enter. 1, hit enter, 2, hit enter, negative 4, hit enter. Then at this point, I'm going to go back and quit, second quit to get out of the matrix, go back into the matrix, second x to the power of negative 1, go over to math, go to my RF. Again, for me, it's easier just to scroll up. When I get to RF, hit enter, go back into the matrix yet again to select the appropriate matrix, which is matrix A. I hit enter. I see I have RF A, so we're going to reference the matrix A. I hit enter, and this is the matrix I get. And what this is saying is this, that there is no solution. Because if we interpret this, this means no solution. Its interpretation would be somehow 0y is equal to 1. Well, 0y can't be equal to 1. That makes no sense. So there's no solution. Okay. Anytime you see something where both x and y column, or the x and the y values in the row are 0, there is no solution. Okay. All right. We're going to stop this right here, and we're going to pick up the rest of the lesson on the second video.